Okay, so welcome. Now we're going to start our discussions and graphing other trigonometric functions, starting with the tangent function. Now, I sketched the graph of the tangent function to show you what I'm talking about. I'm going to go through the characteristics. But again, once we know the characteristics, it's going to be pretty straightforward to graph these very quickly. Okay, and by the way, we're going to focus by focusing on just one of the periods, typically the one that has the origin in it, because again, as you can see, it repeats the pattern every period. Now, notice a couple of things. The period, as you recall, in this case for tangent, is only pi, not 2 pi. So again, here's the general form of a tangent function. So we've got a, which is the stretching factor, right? Same as before, same when we were dealing with sine and cosine. And then we've also got b here. Now, we could have c and d for the vertical and horizontal shifts, okay? But right now, we're just looking at a and b, the stretching and compression factors, okay? So the stretching factor is a, so basically, again, vertical stretch or compression. And then we have b, which is our horizontal factor, which is going to be either an compression or an expansion in the horizontal direction. Now, the period, in this case again, is going to be pi, right? It's going to be the pi divided by the absolute value of b, okay? Now, just like, remember with cosine and sine, it was 2 pi. So again, we're taking one revolution is just pi, right? So now, if b is 1, then the period is just pi, right? But again, because we have this stretching or compression factor, that could affect that. So the period is going to be generally pi over the absolute value of b, okay? The domain is going to be all real numbers except where this is true, where x equals pi over 2 times the absolute value of b, plus some multiple of pi over the absolute value of b. So in other words, what this is saying is, if we take the period and divide by 2, right, x goes through the origin. So if we go 1/2 the period to the left or 1/2 to the period to the right, that's what this is saying, okay, then we're going to have a value of x that is not going to be in the domain, and as you can see, that's where the vertical asymptotes occur, okay? And as you can see, if b is 1, then you can see that they occur at pi over 2 plus any multiple of pi over 2. So pi over 2, pi, or excuse me, pi. So it's pi over 2 plus pi in this case. So pi over 2 plus another pi, and so on. So that's where the asymptotes occur. So the domain is going to be everywhere except where the asymptotes occur. The range, on the other hand, is all real numbers. As you can see, it goes down to positive infinity, up to positive infinity, or it should be down to negative infinity, up to positive infinity with no breaks. And also, by the way, it is an odd function. You could see that. You could rotate this by the around the origin, and you're going to get right back to where you started. Okay. And again, what we're going to do is when we graph these things, we're going to focus on just one period that includes the origin, because if we know one period, then we could just copy that and continue it on in both directions if we wish. But that's it. That's the characteristics of the tangent function that we are going to use to graph this thing and answer problems. Have a good day.